Thank you. No. Turn off the sound and then the pressing it. Okay, well, hello, welcome. I see a lot of people for the first time, so good to know that the community hasn't died since I left. In fact, it probably grew. First thing we need to address is the cringe in the title. So this was like in January, and I was in Belgrade, where I live, at the C++ meetup there, and we were like, yeah, I should, I mean, not like we, but someone said you should make a talk for the next meetup, and I had no idea, so I went to Gemini and I was like, what's up? I need an idea for C++ talk, and it gave some like pretty basic ideas like modern C++, maintainable, and all that stuff. So I was like, no, like I need something different, something wild. And here we have some better selection of the topics. So we have this one, which is like the self-modifying code. By the way, not the reflection, but like the OG self-modifying code. And then there is like writing C++ compiler in C++, shortest possible hello world, abusing the preprocessor. And okay. So if you need an idea for a talk, there are some. But I chose this one. I was like, okay, bro, love the idea. Tell me more about it, and it gives some basic overview, and like it starts off by saying like it's dangerous, like don't do it. It first off lists the reasons why not to do this, and it gives an example that doesn't actually work, but he tried, and we can blame him for that. And what the talk could cover, with some notes, which again, he comes back to not doing this, and also this doesn't really apply that much. And I say, okay, like give me some stuff that I can use to research this, and he gives me, well, books and stuff that takes too much effort, the effort I wasn't really willing to put in for a meetup talk. And I say, no, like I need some like articles, maybe papers, like not books. So I'm not gonna read 5 books in a month and then make a meetup talk out of it. But he goes back to just this huge stuff, and I'm like, yeah. Also, he was really focusing on Intel, and I'm like, I have AMD CPU. It's also not really relevant, but I didn't know it at the time. Again, annoying with the stuff. Yeah, this is too much for that, and I'm like, okay, thanks, bro. Love you, bro. And he says, you're very welcome. Love you too, bro. This is very important. Like if your bro doesn't say I love you too, that's not a real bro. That's just an acquaintance. And speaking of love, is the holiday season. Now, some of you that were at some of my previous talks know about this, but those of you who do not will be acquainted. Hallmark Countdown to Christmas. Basically, Hallmark every year makes Christmas movies that go from October, from like right after, or maybe even before Halloween, all the way to the Christmas. Now, this list does look overwhelming, I admit, but like Mistletoe Murders, that's a TV show, and it's not really in the Christmas vibe. So it's more like end of the season when you're like transitioning back into the real world, so you can skip that. Finding Mr. Christmas. It's like a reality TV, and it pains me to say, but it's not that good. And also, like last year, S.r.o won, and he has charisma of 3, and I don't know why, but Elijah was much better. Yeah, you can skip that also. Baked with Love, I would say it's good, but I'm just a sucker for a cooking show, so also like those 3 are TV shows, you can skip those. The rest are movies, and they're good. I mean, in my opinion, but I love these movies. Okay, yeah, I didn't have an introductory slide because it's usually the same people, so I need to introduce myself. I'm Miloš, so I was here. I moved back to Serbia like last December. I was here for 2.5 years. I worked at Pure Storage, and when I got here, I was like, I should organize some meetups because no one else will. So I've been working as a C++ developer for like 7.5 years, and then I stopped working for like 7 months. In that time, I was volunteering at the children's shelter. So amazing. I still do it on the weekends if I have time. But then I got a job and actually moved to Rust, which was an interesting move. I actually found working in Rust more enjoyable than I expected. And currently, I'm actually taking some university courses so that I can work as a elementary school teacher. So yeah, that's not really important to this talk, but it's if anyone wants to talk about it, it's actually quite interesting. Well, it is to me. So the LLM bro said the talk could cover the history, the dangers, the technical details, live demo, and then alternative approaches and the security implications, which again is like pretty much the same as this, but you know how it is with the LLMs. So let's start with the history. Okay, Wikipedia. I don't know if I pronounce it in English. Demonstrates, so this is like back in 1948. It had the ability to modify its instructions, and basically treat them exactly as data, and it was rarely used in practice. So the definition is self-modifying code. It's code that alters its own instructions while it is executing. Okay, yeah. So this is I was thinking of whether to leave the second sentence or not, but like this is when the modifications are intended and not accidental, which happens, and then it's bug or a virus. No, well. Technically, virus is not a bug. It's intended to behave. But I would say misbehave, but again, it's intended to be bad. Yeah, I say buffer overflow stuff. Okay, so some of the techniques like overlay existing instruction. Basically, you have some instructions and then you execute some other instructions that change the existing instructions into something. There will be examples. It's much clearer there. And also I haven't went through the presentation since February, so I don't remember much of the stuff. You can also create like whole new instructions in memory and then execute them. It sounds like Python has something similar. Like, I mean, Python is interpreted language, it's not compiled, but you have a function eval and you just put Python code there and it's like executed and you can do it on the run. Okay, so there is this like mini compile. Yeah, so like you can create some code and then compile it and then execute it, and then you can just create a whole program and then execute it, which I don't know if that really should be counted as self-modifying code because you are just creating a whole new program. But it's on Wikipedia, so it's true. So the dangers, just like don't do it. We have better ways of doing things. Like it used to be done for a good reason, and that's back when good reason. The hardware is much more limited in terms of memory and the CPU and stuff like that. So you use these techniques to overcome those limitations. And like, if I remember correctly, like there were some instructions on some old hardware, like on some older hardware, you couldn't even have certain instructions. So the only way you could simulate it was by doing this like modifying, but it's not really relevant this time. Okay, like the things to consider is like, do you hate your colleagues? Do you hate debugging? With the debugger? Do you want your colleagues to hate you? The first and the third are not the same thing. Are you programming out of spite? Because yeah, this isn't something that is really doable. And are you really sure you know what you're doing? Probably not. And if you think you do, just reconsider it again. But yeah, the code is not readable. It's difficult to understand. It's impossible to debug. Like GDB will crash if you change the instructions and try to debug the code. Then yeah, also other people will hate you if you do it, and then they need to debug your bugs. So that's the topic. Yeah, these are some of the this is some of the research related to self-modifying code. And it's usually about like malware and its obfuscation and also crime. Yeah, this is a great, this is like my favorite title. So the technical details, basically three methods or like three ways of doing this, just-in-time compilation, interpreted languages, and assembly. This is, I think, my split in assembly.
Can you maybe disclose this assembly technical details?
What do you mean?
Because just-in-time compilation I can understand. Interpreted languages and well, I can understand. Assembly.
There will be examples, but basically in assembly everything is just instructions, and you have assembly instruction that writes assembly instructions over the existing ones, and yeah, there are going to be examples. This is just to satisfy the LLM generated template. So the just-in-time compilation was notably used in Java, JVM. You basically compile the code into some bytecode, yeah, some like not machine level, but also not Java level code, and then the JVM takes the code and compiles it basically during runtime when it can actually make changes and optimize as needed. Yeah, based on the information. Eval, this is most notably in Python. So basically you have a function eval. Yeah, that's like an example. You just put Python code there and it's like parsed, and then so it's parsed, compiled to bytecode, evaluated, and then the result of the evaluation is returned. It's limited in terms of what you do. I think you can have like if-else branching and stuff like that. But I don't know, maybe that's changed in the
JavaScript eval, you could just write their functions there.
Yeah.
You just define functions on the fly.
It's, I think, similar here, but it has some limitations. And this is the case for like interpreted languages. And then like in assembly, you can just create instructions in memory. And then, yeah, sometimes you need to clear the CPU cache because maybe it already preloaded the instructions, and then it's not going to see the ones that you created on the fly. And yeah, this is, so this is like a move to, let's say, C++. This is basically how we think of memory, the heap, the stack, the code part, the global static and stuff. But like in reality, it's just memory. It's like ones and zeros, and it's all about how you interpret those. So like the examples I mostly took from C examples, but like in reality, C and C++ are just syntactic sugar for assembly, because it compiles down to assembly, and anything you can do in assembly, you can do here. Yeah, so okay, this would be an example, but in essence, the way you do it is like you first compile your code, then you disassemble it to look at the actually generated assembly, find what you need to modify. Like you need to, what you need to do is, So like this part, no, but this code, or as it called text part, it's on a page that's read only. You can, by default, you cannot update it, but you can just change that part of memory to be read and execute. To be write, read and execute, and then you can write to it. You write whatever you want, and then you change it back to read and execute, but you don't really have to. And as mentioned clearly, instruction cache, but I haven't done it and I didn't really need it. But in case you try this and it doesn't work, maybe this is the issue. Yes, so there is hot patching, and this is like a technique that actually exists. In essence, like it started from MSVC, and I love how the planned and the GCC added flags for it, added flags and attribute, but they prepended the MS just to be like, this was their idea, not ours. We will have it, but don't blame us for it. Basically, you get some no-op operations at the beginning of function, and in there you can add a jump instruction, so that when you call the functions, you can when you call that function, you can actually jump to some other function. I think like it's used sometimes for debugging, I call a function, and then I jump to my function that does some logging or whatever, and then I jump back and then execute the function that I actually wanted.
Does it mean that every function will be prolonged with these knobs?
If you use the MSVC thing, yes. In GCC, with the attribute, only the functions that you tag with the attribute.
Also, it's attribute for GCC.
Yeah. Yes, there will be again an example. Yeah, and it's also like this standard for making changes while the program is running. So basically, like the way I understood it is, you have some function and in some DLL, then you realize that actually you have a better way of executing. Well, you have like a better algorithm for the function, something like that. So you do this hot patching where you I think load the second DLL along with the first one, but then, well, no, actually you the main part which is calling the function. Now I'm getting confused. The point was that if you have like an alternate implementation, like other than debugging, if you have an alternate or better or bug-free implementation of a function, you can just use this technique, and whenever the function that's actually bad is called, you will jump to the implementation that's actually fine. And in the end, you will do a return, and it will return back to the original caller. The point is that you don't make a function call so that you don't put a new function on a stack frame. Yeah, that was a pretty terrible explanation. I think you.
By the way, why the famous use of this is in Linux live page, which allows you to update your kernel without rebooting the system.
Yeah. Okay, live demo with extreme caution, but actually no caution at all. Oh, it's gonna be difficult. Okay, so first, I probably should have duplicated the displays because this is going to be painful. I assume that the font is too small. Where is the plus? How do I zoom in?
Plus is in place of one.
Oh, beautiful. Maybe it's actually not too late to duplicate the displays, because this is not going to work.
Press the Windows button.
And
Yeah, I saw that that's what you wanted to do. Sorry.
no, I want to, instead of extending the display, I need to. Yes, and
So go to the displays menu. There's Windows, red display.
yes, but it's not showing up. This place. Maybe the Zoom is blocking it from doing something.
Very good.
I pressed. It's there, and it doesn't show up.
Aha.
Maybe
Wow.
this-
Here it
yes.
is. Yeah.
It's
Zoom is-
big.
Yeah, but it doesn't want to show. This is
No,
fine.
I think maybe you just need to move it.
Yeah, except that it's difficult to move.
Yeah,
Mhm.
but
It doesn't
okay, I
want.
think wait,
Just
wait,
move
wait.
the zoom window away.
Yes. Or just close it because we don't need it anymore.
Yeah.
Good.
Okay, so
Mirror.
uh-huh.
And just hope for the best. Stop. Look, we have a camera. Okay, let me go back to sharing. There. Good. Okay, now it should be easier. If only Zoom would go away. Okay, so this is the basic assembly code. Now I'm not an expert on assembly, so don't ask me too much. But in essence, there is this section data where we have the variables. And there are three variables like number one, number two, and the result. Then there is the text with the function start. And the start is where the execution actually starts. And the function add. And add moves the number one into the AL register, which is like an accumulator. Then it adds number two to the AL register and then adds the value from AL into the result and then returns. And the main function just calls add and then does this thing that we will maybe comment out for now, but if I can find.
Hold shift and press the button and write from P.
Right from P? No. I don't think. I think I need the.
Copy and paste the one left from the number one.
Copy paste works. Okay. And I'm going to need my commands because I'm not doing this live. Why does the okay, this will just compile the code and then it needs to be linked. No.
So you actually put some.
Additional characters, you're doing some probably color.
Yeah, I'm struggling with the. It's actually now I see it's actually really good that I copied all this. Permission denied.
Because it's not allowed, you are not allowed to execute this file.
Why not?
Because it doesn't have the execution permission. Yeah, you have to add execution.
Yeah, I didn't need it, but okay. Okay, plus is shit one. Is it plus X? No, okay. Okay,
It's not mounted with no exit.
permission denied.
Copy to temp.
I need to use a dot before dim code of chmod.
No, you don't have to.
But he is not a user.
You know what? 777. Permission. Okay, okay. I have.
And the flash disk which is mounted with no exec. You have to copy it to temp.
Oh yeah. Oh yeah.
But the system does.
Yes, I'm gonna need to copy this. Oh, god damn it.
Okay.
And now people, okay, we need to stop sharing because there is
Social media.
so this is no, there are also some papers here, so it's not great. Self-modifying code. Where do I copy it? Can I copy it just to home?
Well, please go to Informa. Here, go to test. Yeah, there's a folder named test.
Yes, yes. This
Open that.
test.
Yeah, and paste it there. Yeah, open that. Now we're.
Okay. Open it. Code. Amazing. Yes, I trust the others. It's probably a bad choice at this point. Will this? No. Will this run even without compiling again? Let's just hope. Permission denied. Still. It's gonna make me sudo this thing and it's not my laptop. This has been code. Yes, yes, yes. Okay, so let's just print the result. Yeah, also like actually printing stuff from assembly is surprisingly difficult. So I ended up.
You share the screen.
Yeah, you have to share the screen.
Yes, I need to share the screen on Zoom. Thank you. Share, and there is something in the chat.
The
Share.
camera is on, so it was visible all the time.
Can I actually go to let's see, system window capture, and now which is the real one, as this one is. I hope I'm sharing this one. I don't know what to say. Okay. Why is the Zoom not working? Control 1. Okay, is this okay? Okay. So if I go back to the actual file, okay, we see that the number 1 is 5, the number 2 is number 1 is 10, the number 2 is 5. If we add them, we get 15, and then if we add them again, we get 30. And so this is like the standard stuff for the exit. This is just a 6 call for exit. I mean, I just found this on the internet, so I can't really. The point is that I'm returning the result, which is the result of these 2 additions, to the as a return value of the execution of the program. So we should get 30, and we do get 30. Now, if we look at, let's see, read off. This is going to be very tiny. Oh, cool. So, okay, some information about the program itself. The point is that, so this is the code page, and it has read and execute, and this is, I think, the memory, which is read and write, and then there is this part which is just read. Yeah, the first segment is just a segment. The second one is text segment, which is the code, and the third one is the data. And yeah, because it's read and execute, if we do this, now this is the actual modification part. So basically, I'm going to put the 42 value into a place that's like 7 bytes from the add label. Now, how do I know that it should be there? It's, oh, I can't click on readme, amazing. It's because, oh, I don't have op jumps here. Nice. Okay, I'm just gonna use the other pin code. So if we disassemble the binary, we see that basically this is what it compiles to, and the point is like this is add. These are the instructions in the hex format, and then we have add instruction here, and we see that like this is where it starts, and we see that this is the address where the add function starts, or where the add label is, and this is where the add instruction is, and it's like 7 bytes. 7 bytes from this, so that's where we want to move things. Now, in case you're wondering, 42, it's a instruction for a subtract, and how do I know that? I just put sub here and then compile and see what I get as a value. Now, okay, first let's try. No. First, let's try just recompiling and rerunning if it lets me. Okay, I need to save this. Readme. So while I'm struggling here, you feel free to chat with each other. Just the silence is too awkward. Control. No. Okay. Yeah, segmentation fault, core dump, because yeah, we're not allowed to do that. So we saw in like readelf that the page is read and execute, and it doesn't have write permissions. So we would need to change a certain byte somewhere. If we do hex edit, there is probably a better way of doing this, but there is also this way. If you look at hex edit, you know, there is a byte here that's a 4 and needs to be changed to, that's a 5 and needs to be changed to a 7. If you can do it, then you know you figure it out. But what I did was I had the Gemini generate a script that's going to find the byte that I need to change. Yeah, so it's here. So it has 1 0 0 0 0. Yeah. I need to find it. I need to find the pattern 1 0 00001. It's maybe this one, but it should be a 5, not a 7. No, it's this one. That one. Yeah, like I actually tried convincing Gemini to. Why won't it change? Oh, wait, I need shift. Nice. I tried convincing Gemini to write a script that actually. Did it change? How do I? No, it didn't. The control Q is not working, and the Gemini did like. How do you quit? How do you? Okay. Unknown command.
I have no idea what editor, how.
This is hex edit. It should be just Q, just button Q. Yeah, but can you edit it in Octeta?
Yeah, just write Octeta instead of Octeta.
Okay, let's see. Someone else had.
Octeta with K.
Okay, let's see. Oh wait, I'm gonna have trouble with this. Octeta. Let's just restart this.
The documentation says Control X to say.
Control X. Okay. Okay, thank you. This should not be this difficult, but okay. Yes. Will it now work? Yeah, this example should not have taken this long, but okay, we finally got it to work. And if we find the command, we see that it's 20 because first time we added 10 and 5, which was 15, and then the second time we subtracted 5 from 10, which is 5, and then we added that to the 15 and we got 20. So it works. I mean, this is not really a useful example, and it should not have taken this much time. But yeah, the point is in assembly, well, once you get over the issue that you're not technically allowed to change the code, you can just write bytes because it really comes down to just bytes, and you can see them here. Now, the hooking example. So, attribute ms hook prolog. So you put this attribute to the beginning of the function, and is going to add those bytes, and this is like just a function that I'm going to use instead of it. The main is simple, so this is the address of the function that I want to. Yeah, I'm having real trouble with the terminology here. So like this is the function I want to be hooked, and this is like the function that should be executed when I call the function to be hooked. The function is called, and then the hot patch happens, and then the function is called again, and we see the result. The hot patch is first the page is made writable, and it's made by get the page size, and then like basically the function itself is not necessarily at the beginning of the page, it can be anywhere. So you get the address of the function, and then you do module page size and subtract that, and you get the actual beginning of the page. And then there is just a function mProtect with the address, the page size, and then you put the permissions, which is like read, write, and execute all of them. Yeah, those are from the Linux. Wait. Yes, we are in the hooking example. And then hopefully this works. So it's just refusing to select the README. Enter this GCC. Yes. Also, you will notice that I have V all, V error, and V extra, and V pedantic, and it didn't complain about anything. So this is completely valid thing to do, in spite of what the AI would want to tell you. So let's just look at the assembly. The init is not important. But I don't even know. Or is there what? I think this is because of the. Okay, I'm gonna need to do a control find. Yeah, I mean a lot of stuff is included here, so to be hooked. So yeah, you see this LIA, which is like load effective address of 0. This basically does nothing, and these are the bytes that are supposed to be used to do the hooking. And then this is the actual body of the function. And you see that the hook function doesn't have those knobs at the beginning. It just starts with the end bra and then pushes RSB. Basically the same function. It just does multiply instead of add. And let's see if we execute, and I'm gonna do a copy again. See, should be fail to hold where's the function again. Wait. Did I make the changes? So okay, it's not allowing me to make the page writable. What? As an it's possible.
To change the attributes of the page.
To make page writable, but it's not allowing.
Yeah, it's not allowing to make it executable again. Am I gonna have to do this as a super user? Let's see. Where is the
What are you looking for?
comment
Why?
slash? Yes.
Shift and the button right from B.
Shift and right and right. Let's see.
It's easy, just press Control Alt Shift.
Or I just like I just deleted the code because what's the point of commenting it out? Yeah, it hasn't really occurred to me that I should be. Yeah, it works if I don't try to make it read and execute afterwards. But oh wait, I think I changed make the and protect is going to return 0. Yeah, I think I made some last minute changes. Yeah, not update all of the places. You should return 0 and it yeah, okay, now is not the time to debug.
The return from make page writable. You check it's not 0. Right?
Yeah.
Return from make page read and execute. You don't check it.
I mean, okay, now is
Check it to be equal to 0.
what did I press? Page read and execute. So yeah, don't make last minute changes before. Yeah. I hope Looks like that was the only place I didn't update the code. Nice. But okay, I think we lost our way. Or maybe not. Yeah, this was longer than it should have been. But okay, are there any questions for like this part? It's in essence, it's like the underlying machinery is maybe complicated and like understanding hardware and stuff, but in short, you just put the attribute name as hook prologue, and then you will get in the assembly. Get away some. You will get these bytes. You get 8, you get 7 bytes, which is, there are multiple jump instructions, and you can only put here one that takes like 32. Wait, I actually didn't show to be hooked for touch.
As I understand, it just uses adjustment for 8 bytes for 64 bits system. So it adds the 0. And now you can replace the address with necessary. If I understand this.
So, sorry, can you repeat it?
We need here to have 8 bytes.
Yes.
Since we are using 8 bytes addresses in 64-bit system. If you would use 2 bits calculation, I guess it will be just 4 bytes there.
I'm not sure about that. The thing is, okay, if you go to helpers, it will put enough bytes for a jump instruction that takes, because there are multiple versions of the jump instructions, and it will put enough bytes for the jump instruction that takes 32-bit value, and it's the 32.
We're talking about 64 bits compilation, and now we need to just set up any address in our address space, which can be really huge, right? So we can even load, for example, 64 megabytes executable into the memory, and then after loading all of the DLLs or objects, we definitely would use something where we need to jump in, and it will be long from this entry point. You are compiling the very short application, right? So it's clear that you will just set up the read-write execute settings for example, 16 kilobytes or whatever, 64 kilobytes. But if you're talking about big applications, it will be necessary to have bigger addresses.
Yes, but I think that this technique is limited to this. So it will only allow you to put jump instruction, and you can put a 32-bit value that's actually relative to the place where the jump instruction is. So it's going to...
It's not relative, first of all, because you definitely need to understand. You have a lot of dynamically loaded objects in your address space. Your address space is actually protected address space from the operation system.
Yeah.
And you need to put their relative address to the beginning of your executable, which can be also drastically huge. So here you will put not 32 bits, but something like 32 bits, maybe even 48 bits, bits, yeah.
It's called documents in this respect. It uses like the classical E9 instruction, which is like a relative 32-bit jump.
Oh,
It's just the way it's being done. And
yes,
actually, for 64-bit, there is not enough space because there is just 8 bytes.
Right.
And
so the links don't work in the PDF.
To signify the very jump instruction, right? So 64 byte couldn't be jump couldn't be included in a bytes.
Unfortunately, I will share the link on Discord, because somehow when I changed this from Google Slides to PDF, the links stopped working, or maybe I'm not using the right button.
Just maybe say that when we're calling something, right, we are trying to request next instruction to be picked from this specific address, right? So our code segment need to pick next instruction from this address, and that's why this exact from my vision, it is exactly address when we choosing the address which will be executed next.
But we are jumping with
jump instruction
Yeah.
is relative to the address of the jump instructions.
Yeah.
In
this.
assembly x86, there's a special instruction which is relative jump. And it's because usually you don't want absolute jumps because all the code knows where it's placed relatively to each other. But it's put on randomized absolute address because of security. So the actual hardware instructions are relative jumps because it's
Relative
more
to the beginning of your executable code,
No,
right?
no, no,
No, no,
because
relative-
it's to the address of the jump.
So
instruction.
essentially, it's like PC plus equals some.
You are talking about only one module. I mean, like, if you're talking about one executable,
It doesn't matter.
okay, then just try to explain if I dynamically load any dynamically load, right?
Then you can have another instruction which is absolute jump, but it's a different instruction.
It is different instruction, right?
Yes.
It's absolute jump.
Yes, but we're not using that here.
Yes, that's why, but I'm talking about why it's here 8 bytes, because we need to predefine space for this absolute jump anywhere.
8 bytes is not enough to encode an absolute jump. Because you will need at least the
There's one more.
jump of code itself.
That is one more.
right?
Yeah.
So you can't fit it into less than 9 bytes.
On the other hand, if you just put in jump, you don't care about the rest of the functions, you can put it there and just nuke it and because the rest of the function will not execute because you put a jump there, so it's like,
Yeah, technically.
if you put call instead, then yeah, you care, but if you jump, doesn't matter.
Yeah, I mean, okay, technically, yes, also, like, if I don't want to execute any of this afterwards, then I don't care, if I overwrite more than this stuff. So I think this, like, relative jump is more for, it's more like for debugging and stuff, where I want to call another function, do some stuff, and then, like, come back to this function. It's like, it's called trampoline. Like, you jump there, do something, and then come back here, and then finish the execution of this. Hopefully, I will get the links fixed when I update when I put the presentation Discord, and, like, you can go through the stuff I used to prepare this. Any more questions or comments? At least about this part. Okay, and the last part is the optimization, which is just beautiful. There is a magic function, and the magic function is magical. It accumulates values in a vector, and then there is a static counter. As long as the counter is less than 5, we will add the counter to the sum, and if it's more than 5, then we just return the sum. And we will optimize. Optimization. Okay, optimize. Yeah, the compiling takes longer than I expected. Ops dump. Optimize. Forgot to optimize. What? Doesn't have optimize. Oh, I have leftover from other optimization ASM. Okay, we will just look at the magic function. And well, I don't know, maybe some of you are more familiar with the assembly, so you can actually read the stuff. But this is, so I can recognize some things, like there is a call to vector and yeah, so this is a call to begin and end of the vector. And then there is accumulate, and then there is, so there is jump greater than. This is the compare. This is where we are actually comparing the value of the let's see, we are comparing the value of, it's in the amazing value of the counter to 5. Well, technically it's comparing to 4. Yeah. So if it's greater, then we jump to somewhere, like it's this plus 72, whatever. And if it's not, then the point is you just go to ChatGTP, copy the assembly and ask what is what. And if you do that, it will explain that this part here is this is basically the standard ending of a function call. It's going to, I think, move the return value into a register, and then it's going to do leave and return is going to come back to the function that's calling it. And the thing is, we know that like once counter reaches 5, we are going to keep doing this compare and then jump, conditional jump and stuff, which is unnecessary. So we are going to do some magic. We are going to optimize the function, and it's going to be optimized by overwriting. So mem copy wait. I think there is some code missing here. Other instructions that there's just mem copy. Okay, I'm pretty sure this is not going to work. There should be, so basically we have instructions, and the instructions are here. This, you just again look at the assembly, and you see that the values are 8B, 45, DC, it's 48, 8B, 5D, blah, blah, blah. You copy paste, you put it into it's in the helpers. Okay, I forgot where is it. You put it into this. The magic number here is not used anywhere, so it's definitely not going to work. The magic number is actually going to yeah, let me just do the plus is 1, right? Plus equal is not. Where is equals? Do I need to copy equals from somewhere? Do I have equals? I have equals here. I don't know how you manage with this magic number. And now I need this. Beautiful. Okay, the point is the address is actually the beginning of the function, and we actually want to overwrite this. So we want to execute the accumulate part, and then this part, which I hope is actually, no, it's actually the compare part, which I hope is the 78 bytes from the beginning, if this was compiled basically the same with the same instructions, will be overwritten.
You can count, you see the address on the left.
Yes, actually I need to subtract them because like not.
The offsets in the jumps, and then on the left are the absolute numbers. So just look at the jump instruction, which is below this jump D plus 72. So you know the
Plus 72.
493B is offset 72.
So it's 72.
72 is the freebie. So I'm not sure which one you want to override, but
Neither am I.
Save this.
If it's greater.
You can save this assembly and then you read the code.
Because in this instruction, you have the absolute address, which is 493B. And
Yeah,
then
but
you have also the relative address to the start of the function, which is 72.
yes.
You don't have to count it all, but you have a reference which is far enough.
So let's try with 72 and hope for the best. But yeah, this is actually another like big issue with doing this, like modifying code, which is you compile it with a different compiler or different flags and it does different optimizations. Now things aren't where they were. And then if you're lucky, it breaks. But I've had the cases where it doesn't break, it works, but it doesn't actually work. It prints some random result. So yeah, things do happen. Let's see. No, I don't know where the slash is. Wait, it's this. Oh yes. I went through optimize. It actually works. Nice. Okay, now we can actually go back to the example. So basically, first we call this function 10 times and it adds values 1 to 5. Which is like 15 plus 10 times, which is 150, plus we have 1 to 5 values of the static counter, and we get 165. And the next time we do this, we should get 150, and we actually do. So it's actually working properly, which is good. We didn't break it, but the question is like, did we actually gain any performance by doing this? Because that was the whole point. Okay, now I need to again stop sharing and then share this thing. And there are other 4 messages in the chat. Amazing. Okay, there are comments about your PC. Okay. What's a good program to binary patch Vmake? What? I'm reading the message.
Someone asks if he can do something he shouldn't.
So yeah, the answer is you shouldn't. And compared to the load path hijacking and runtime. I don't know about this LD load
Well,
path.
the CPU, I haven't really doing that in runtime. This is usually when you want to replace. There is some deep shared object that you are normally loading and you want to load a different one. So you use this LD load, how is it called? LD load path to force it to load it from somewhere else, which is useful for hacking around some part, like tricking a program that the time is different. For example, you have a 15-day demo, so you just load it with a fake date generator, so that it always thinks it's this.
Okay, so for the actually first question, can I patch legacy software with these hooks? I mean, that was one of the intended uses, but I don't know if that's the best way of doing it.
Well, patching the executable is probably easier than doing this, because this is something you do in runtime.
Why is the screen black? I'm gonna close the chat. Why are my slides missing? Ha. I don't know. So they disappeared. Well, okay. The point is that yeah, I guess something went wrong with exporting the slides to PDF. But the point is, I did like a benchmark to see if I get any performance from actually doing the optimization, and as it turns out, I don't really, because maybe for some more complicated example, it would make sense, but something simple like removing a branch. I guess branch prediction and preloading and all that stuff does the good enough job that there is no point. So without optimization, yeah. So these are the runs, and the numbers are tiny. I can't even see them here. Yeah, but also I think you even get worse performances at certain cases because changing the flags on page actually requires operating system to do some stuff, and the overhead of that is pretty bad. Oh yeah, so this is the perf stuff. I think this is like, oh no, this is, yes, this is perf plus benchmark, and it's basically the same. And if you look at like branch misses and stuff, the numbers are not really that different. It's better like in the point something percent change. And also depending on the run, you can even get worse performance. So this is not like the best way of doing it, but it's actually being done, and this is used in Linux. And I think there are libraries where you can do it yourself for your applications. So the static keys allow basically what I did in the optimization example. So you create this. No, there is no actual example. So this you create a key, and then you have this static branch unlikely or static branch likely, and you enable or disable key. So if this key is enabled, then instead of having if, which basically boils down to compare and then jump, you just get no and you execute this code. And if the key is not set, then you just get jump directly to this. So there is no compare and there is no conditional jump or anything like that. You directly either execute the code or you don't execute the code. And you turn it off with like static branch enable or disable. There is branch likely and there is unlikely and likely. And the difference, as far as I remember, the difference between the two is whether you want the if branch to be the default or the one that's like nope and direct execution, or if you want the else branch to be nope. Yes.
When static key false, is it GCC specific or it's...
No, this is Linux kernel specific stuff. It's not. There is no. At least I haven't actually found a way to do this myself.
Linux kernel has some stuff on itself, but it also has plenty of GCC extensions.
I don't know. It's possible. There is actually, maybe I even find it. It's in a Discord chat in the other. There is actually a library that allows you to do this. And also like one of the big things in the Rust was allowing inline assembly because of the Linux kernel, because they actually like doing stuff like this. Feature. Oh yeah, it actually says that it's a GCP feature. If only I read my slides. Okay, and yeah, he did the benchmark, and he actually found some like noticeable difference, which are still like, I don't know what exactly he was focusing on, but yeah, there are like less branches, and it's like 2 million less branches, and there is like 1 million less branch misses, which like on a large enough code base with enough instructions, that actually makes a difference. I mean, the percentage wise, it's pretty small, but I guess like you're at the point where you're trying to, I don't know if there is like an English term for that, but we say it's like trying to squeeze water out of a rock. So that's basically it.
Probably Synergy is the best way to say the squeeze, just a little bit more performance. But
Yeah, but I like the Serbian one more.
yeah, but there is nothing like that.
It's more poetic. Alternative approaches, like I don't know anything else. Unless you're working on Linux kernel, maybe just avoid this. Security implications, I'm not gonna like talk about that because yeah, you can easily mess up stuff. And also, as I've mentioned, like the Gemini just rejected to, like when I asked it to write me a script to find the byte I need to change, I said, okay, can you just change the byte instead of you printing it and then me looking for it? And he was like, no, not gonna do that.
Actually, replying to the message, likely, unlikely is a different thing. Likely and unlikely are just attributes in C++ that you use to adjust some compiler optimizations.
So
this one
the
is
AI which was mentioned is already deprecated and it was used for the writing the Linux kernel. And if you're talking about what we can do with this technique, I mean, modifying the code, actually, very early and modern virus developers just use, these techniques to write your virus. It's quite easy if you understand that the code is actually the same amount of bytes. That's quite obvious.
Yeah, but if the microphone didn't catch like the likely unlikely thing from the C++, the C++ attributes are not the same as the Linux stuff that I just showed. And I don't know about like discouraged, but I think like sometimes it actually does worse, sometimes it does better. I'm not sure. Haven't really followed it much. Yeah. Okay, any more questions, comments, or stuff like that? But I guess not. Okay, then. That's it. Thank you.